Hello, a very good day everyone. My name is Afiq with number matrix CE200027. Today we are going to take a look on activity 1, which is open loop speed control system. In this activity, we are aimed to observe the input voltage and also the tachometer voltage for the different motor speed. Okay, over here, this is the block diagram that is moving according to the diagram given in figure at point 4. Over here we have the voltage input, which is the step input block, and we have the scope for observe the voltage waveform, and we have this transfer function block, we have the plus minus block, and we have constant block, and we have this gain block. Okay, over here this transfer function block is represent the electrical part, which 0.516 is the EMF constant, voltage induced constant, and we have 0.0218 Henry amateur inductance and 2.518 ohm for the amateur resistor, and the second transfer function block, which is we have 0.221 kilogram meter square, which is the moment of inertia of motor, and 0.002953 Newton meter second for versus frictional constant of motor, Bm. Over here, tachometer constant, and we can apply and break simply 0. Lastly, we have constant. Okay. After I run the simulation, we can see that we can observe the input voltage over here. Over here, for the input voltage, we can see that it starts moving on 1 second period, and it constant until 10 seconds on 240 volts. For the motor torque, it will start from 1 second and it's rise drastically until 46.83 Newton meter, and it will decrease until it reach a constant point, which is 11.13 Newton meter. For the motor speed, as the voltage rise in 1 second, and the motor also will start moving after 1 second, and it rise slowly until a certain point of constant speed, which is, we can see here, 3,686 round per minute. For your information, this motor is have a rating on 3,700 RPM. Then this is proof that the motor has achieved its brake speed. And the tachometer voltage over here, we can see the constant tachometer voltage for maximum tachometer voltage on the 10 second, which is 239.6 volts. For figure 8.5, it remains the same diagram and the same parameter as figure 8.4. The only thing is it adds another tachometer constant at the input speed. And for this one, we can see input is speed. For the previous one is voltage. So what we're going to see over here is we're going to observe the input voltage and also the tachometer output. Okay, since the input voltage is pricing from 400 until 2600, so we're going to adjust over here. So over here, the RPM is 2600. Okay, after we run the simulation, we can see the input voltage is 169 volts, and the tachometer output is at the maximum voltage. We got 168.7 volts. So overall, as we run the simulation, the tachometer voltage will slightly less than the input voltage. Still, it has some copper loss or magnetic loss inside this DC motor. And after we run home the simulation for the motor speed from 400 until 2600, we observe that the input voltage, the motor speed is directly proportional to input voltage and also tachometer voltage.
Hi, Assalamualaikum. My name is MASNI HAZIRAH, BINTI MUSTAFA KAMAL. My matric number is AE1900009. So today I will present for activity 2 in exercise 8. So first, I need to find the input voltage for input speed when it is 250 RPM. So I run the simulation. We can see that the input voltage that I get is 162.5. Okay, and then by using input voltage that have been obtained, to find the speed output by varying the brake scale according to the value that given in table 8.3. So to find the speed output, we change our circuit look like this, and then input voltage we change it to 162.5. And then we run the simulation, and we get the speed output is for brake scale 0 is 2500 RPM. And then when we change the brake scales to 21, the speed is decreasing from before when the brake scales is 0, and we get the new speed output, which is 884.6 RPM. So from there we can say that the relationship between speed output and brake scales are inversely proportional, as when the brake scale is increased, the speed output will be decreased. So that's it from me for activity 2. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Afandi bin Muhammad KHUSRIN. My metric number is DE30401. In this video, I will explain about the activity 3, which is the closed loop speed control system. Okay, this is a connection in a MATLAB software based on this figure, block diagram for closed loop speed control system. Okay, first we set the input voltage at the 162.5. We get it from the activity 2. So we set a proportional gain, which is 200. So we set it 200. The saturation 240. Okay, set it 240. So upper limit 240 and the lower limit is 0 volt. Okay, the question is want to find out the motor speed at the this brake scale 0, 3, 6, 9, 12, 15, 18 and 21. So we start with 0. So this is 0 brake scale, so we run it. So we click here. We must find out the motor speed at the t 10 seconds. So we set the measurement here at 10 seconds. So it located at here. So the value of the motor speed in RPM is 2488 RPM. So we can use it into this table. So we can write it into the table 2488. So we change it to the next brake scale, which is a 3 brake scale. So we run. So we find out that the value at t10 second is 2487. And then we change it to the 6 brake scale. So we run the simulation. So we can find out at the t10 second is 2485 RPM. So next we change it to the 9 rate scale. So we run the simulation. So the speed is 2484 here. So we change it again to the 5 rate scale. So we run the simulation, and the speed of the motor is 2483. So we change it next to 15. Okay, 15. So we run the simulation. So the value is 2482 RPM. After 15, we change it to the 18. So we run the simulation, and the motor speed is 2304 RPM. And the last one is 21 brake scale. So we change it to 21. So we run the simulation. So we choose that the motor speed at T second at 21 brake scale is 2073. That's all from me. Thank you.